Hello and welcome to Pep Talk with me, Mr. Pepperell. In this episode we're going to find out what are alpha and beta particles. By the end of this video you should be able to tell me what alpha and beta particles actually consist of.
Now, before we get started on this topic, if you're in any way unsure what I mean by the term isotope, it's probably worth you checking out my Know Me a video, What is an Isotope, before you carry on with this, as that's going to make things a lot clearer for you. So now we know that an isotope of an element has an unstable nucleus that will decay or emit a particle to become stable, and it can emit one of these alpha or beta particles. So now we need to know a little bit about what these two particles actually are. So let's start with an alpha particle. Now, an alpha particle consists of a number of things, namely protons and neutrons, and in fact it's actually got two positively charged protons, two neutral neutrons that have got no charge at all. So we can see that its overall, or its relative charge of an alpha particle is 2 positive, or it's got a +2 charge. And if you have a little look at that particle there, you might notice that 2 protons and 2 neutrons is actually the same thing as the nucleus of a helium atom. That's just a sort of fact that you might want to remember as well. Okay? Now, you should remember from chemistry the term relative mass, okay, which is actually the top number of the element symbol on the periodic table. And what this number is the number of neutrons that we've got there too, plus the number of protons. So you should be able to see that the relative mass of an alpha particle is going to be 2 plus 2, which is 4. And we can actually represent an alpha particle like this, okay? Here's the sign alpha for our alpha particle. We can see it's got a relative mass of 2 neutrons plus 2 protons, so 4 there. And of course this bottom number here we know is the number of protons, which in this case is 2, but that number here also shows us the charge of the particle, which is positive 2. Well, what about the beta particle? Well, a beta particle is actually made up of a single high energy electron. Okay, and we know that electrons are negatively charged, so what we can straight away say is if we've got one electron, one negatively charged electron, the relative charge of a beta particle is -1. Okay, now electrons compared to protons and neutrons have got no mass. I mean, electrons actually have got a little tiny bit of mass, but when you compare them to neutrons or protons, they haven't really got any mass. It's negligible. It's not worth talking about the amount of mass that they've got. So what we can say is because a beta particle is not made up of any protons or neutrons, it has a relative mass of 0. Remember, the relative mass of an element is the number of protons plus the number of neutrons. Because this beta particle hasn't got any protons or neutrons, its relative mass is 0. And we can represent that beta particle like this. We've got the beta sign there. The top number, remember, is its relative mass, which in this case is 0. No protons plus no neutrons gives us 0. Down the bottom we've got the relative charge of the particle. Well, the particle is made up of one electron. Electrons are negatively charged, so we've got a charge of -1. So in your notes I think it might just be worth you knocking up a little summary table like this, where you've got the two particles we talked about, the alpha particle, the beta particle. Make a note of what they're actually made up of. Okay, so here's 2 protons, 2 neutrons, and a single high energy electron. Okay, what the relative mass of each particle is, in this case it's 4, in this case it's 0, and what the relative charge of each particle is, in this case it's +2, in this case it's -1. Now you might notice from when we talked about the 3 types of nuclear radiation that we are missing gamma from this table. Well, don't worry, gamma is going to get mentioned next time. Don't worry about it for the moment.
So that's everything we need to know about alpha and beta particles. Any questions about that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.